So the topic for this session is composite materials for energy storage and applications. And this is my honor to introduce the resource person for this session, Dr. V Reddy. Sir is a senior professional researcher and group leader in energy storage technology at NMG Montreal, Canada. He received his PhD in material science and engineering from University of Bordeaux in 2003 and previously served at the Department of Material Science and Engineering, National University of Singapore from 2003 to 2019 and the Center of Excellence in Transportation, Electrification and Energy Storage at Hydro-Quebec from 2019 to 2021. With over 25 years of experience, his research spans materials for energy storage, nanotechnology, composite materials, materials processing and characterization, energy and environment, and in situ techniques for electrochemical energy systems. Sir has published 235 peer-reviewed papers, including a highly cited review in Chemical Reviews with an H index of 78 and 22,000 plus citations, placing him among the top 2% highly cited researchers globally in energy and among the leading highly cited researchers in material science in Canada. He serves on editorial advisory boards of leading journals, has delivered 240 invited and plenary talks worldwide, and has received multiple mentorship and research awards, including the 2021 Battery Materials Electrochemistry Award from Electrochemical Society of India at Indian Institute of Science. We are really fortunate that such an eminent personality we have as a resource person for this session. Sir is already present right here. And I will request Sir to please start the session.
Thank you, madam. Hello.
Yes, sir. Sir, please go to the slide show.
My slide is visible?
Yes, slide is visible.
Okay, just I want to know why my slide is okay. 1 minute, I had some issue. I know what is the reason. Can I go out and then?
Sir, what's the problem?
Because 2-3 slides are, maybe it is not correct. Wait 1 minute.
Okay.
Okay, again, sorry for the delay. So I'm going to share my slide now. I think now it is visible. Okay. Yes.
I think, sir, your home screen is visible. Your home screen is also visible. You just drag it.
What about my slide number 2 is moving? Slide 2.
Sir, actually, your home screen is also visible. You please drag it to the left. Bahar.
Yeah, now it is okay.
It is okay, sir. It is okay. You can continue.
Okay. Okay. Again, without any further delay, I think slide number 2 is now is okay.
Yes, sir. Okay. You can continue.
Yes, sir. Yes, sir.
Okay. Okay. So that I don't want. Okay. So once again, thank you for the Animesh Talapatra and all the FDP organizer for organizing this excellent FDP. In fact, I attended for a few, except today because previously due to the hard time. So attended few talks because in fact it clearly shows that this FDP attracted a large number of participants all over the India, and also it clearly shows the importance of this particular FDP. And In fact, I've seen the talks with covered the various topics related to the composite materials and that applications, and mainly some talks are really relevant to the computation, simulation, etc. So since I'm last person in this presentation, so I'm going to make it more simpler so that since you people are already exhausted with various topics, I'm going to little bit make it more inspiring. Just I'd like to tell a little bit more what, for example, I think people are using that batteries and what is the composite, what is the inside, really, what is the exact component, composite material inside the battery, electrode, etc. So that are used in your electric vehicles or smart grid or various other applications. So previously I was at National University of Singapore. In the last 6 years, I was at based in Canada. In addition to other beautiful season, again we can see some extreme during this time with low white color snow. You can see all over the place. So this is my outline of presentation. Before I'm going to introduce. So again, I think since we've been a lot of teachers and then some faculty, some students also there. So research has no boundary. In fact, these are the few examples at the NUS at we've been trying with various categories, starting from junior college and various undergraduate researchers. So again, we published various publications. Mainly, I can tell that composite. I'll tell you later what is the meaning of the composite in my terminology. And then, like as many students have been participated local and international conferences, and few other outreach we have been done. So these are the small groups been trained at PhD students within NUS and also few other part of the world. They visited our lab and then utilized the things. In fact, as you can see clearly, widely contributed with the various within NUS and India and also few other part of the world. We've been mainly collaborated, especially students exchange. They visited our laboratory and then mainly PhD students utilized our lab and then so they finished their PhD in their respective universities. So today I may focus on, I think today we've been heard some particular presentation. Maybe now I'm going to make a little more depth on how especially lithium or sodium based composite materials are used in the energy storage in particularly if you run with electric vehicle and what are the real challenges. Although actually the composite material really very wide. In fact, it depends on the especially any research area you take composite is a really it is very very important. I'm going to explain in the later. For example, in polymer electrolyte, we here also we use the solid polymer electrolyte composites also we use, including the any area, for example, supercapacitor, all the area we have to use the term composite because there we use something like binder and come graphene or some composite carbon-based materials to improve the electronic conductivity, etc. Again, sometimes if you talk about the alloys, there also we call as composite. Again, the terminology will be different. So coming to the material, I think already people have been previously discussed about the importance of materials. I think we are using from the long time. As you can see, like especially starting from especially silicon age is the revolutionize our technology. In fact, due to this one, we're able to, for example, a lot of miniaturized devices, including iPhones, and then a lot of advancement is happened thanks to the silicon technology. Again, 1980, as you can see, that we call as composite age. So as you can see, this particular FTP has been covered with the I think, although it is really old still because after 1980 there is a lot of advancement is happening because of the lightweight material and including aerospace and then various other applications. In fact, the previous speaker are talking about the various categories, how the especially if we talk about the polymer composites or ceramic or any type of the alloys, super alloys, etc. Again, the all comes under the composite material, lightweight material. Again, you can see that all under the composite material. Due to this advancements of this particular technology, now compared to the one time, the aerospace technology, especially lightweight aircraft, has been already come thanks to the composite technology. Year 2000, we call as a functional material age. Again, we call as nanotechnology. Again, so again, the same area. Sometimes some people, if you talk about more depth, you go. Again, we call it nano composite. Again, so since some nanometer, nano fillers, people have been used in this particular applications also. So again, year 2020, we call it molecular age. Future, always we call it intelligent and low carbon age material. A lot of the research we do, either composite materials or any type of materials, at the end, always you have to think about the how to reduce the CO2 emission irrespective. So these are the, so I think lot of priority for the, especially all over the world. Always people are looking how to reduce the CO2 emission, etc. Now, I think previously, I think this FTP has been covered with the various materials, talking in terms of energy, environmental protection, and some materials are discussed. I think my previous speaker already talked about the healthcare, importance of material for healthcare, and especially, for example, composite membranes also they're used in the, especially filter the water technology, etc. So again, we broadly classified the materials based on the applications. Again, we call as a building material, construction. Again, you can see. So if you talk about civil engineer, there also we call as sometimes in order to make some good property, they may use some particular composite or particular things they cannot take a good properties. For example, sand, wood, concrete, and granite. These are the unphase change materials. Again, this will vary depending on the geographical location. And electronic materials, silicon, germanium is one of the important materials that are used in the solid state electronics and any type of the devices. And again, the energetic material. Engineering material, for example, people already this conference, people have been, few talks have been covered with the super alloys, again, the or iron, steel. Again, for example, the steel itself, the inside, if you go for more metallurgical thing, there are lightweight alloys, again, the magnesium, some few other lightweight materials have been used in this particular category. Again, food and pharmaceutical, based on physical properties, we broadly classified metal semiconductors, again, magnetic material, optical material that are used in the, for example, photonics and then electrochromic devices, etc. Dielectric and radioactive thermoelectric materials are also used in the various applications. Again, today I'm going to touch up some what is the importance of energy storage material that in the electric vehicles, smart grid and portable electronics. Again, CO2 capture and storage, again, there is also really challenge sometimes people, especially the industry, there is a, so people, they wanted to uh, capture the CO2 so that to reduce the further emission, etc., CO2 emission. So again, another thing is the information in science and engineering. People always irrespective of all the things. I think we need advanced multi-scale modeling. In fact, of the not only new materials, composite, etc., etc. And again, you can see that the people may ask you. I think previously people are talking about what are the importance of the modeling. Although so we sometimes experimentally it will be difficult for us to verify. Irrespective, I think the modeling is really useful. For example, so you don't need to invest in huge millions of dollar things. People with a simple modeling approach, nowadays some, for example, various modeling to really tell that feasibility of this process, etc. So again, I think quickly I'll go through, for example, here the mainly wood as a main source for the main building because the climate conditions and also they need a thermal insulations because of the extreme, sometimes may go to minus 20, 30 to retain that particular temperature. The importance of steel, as you can see that fancy building are also some, again, if you talk about the aluminum with the aerospace industry, or if you talk about carbon fibers, are also used in the, for example, aerospace X. That's why due to this one lightweight material been used. Now coming to the optical science, again, if you talk about the electrochromic devices, I think color display, again, as you can see, there is a lot of advancement is also is happening. Again, I'm talking about this one more on physics. So if you people are focusing on the photonics area, etc. So again, the thermoelectric material, again, this is also very important. I think air conditioning and especially the superconductors, again, for example, laser cooling, etc., especially for biological samples, or if you talk about the TM, etc., there is a we need a cooling system again that is in the this particular applications. Again, I think, for example, waste heat recovery, especially automobiles, also they used in this particular technology. In general, advanced materials are used in the various applications, not only energy and environmental care and few other applications, etc. As you can see clearly, I think I covered few still a lot of, although we climb it is the most of the times is the composites also play in mostly sometimes, for example, you talk about the coating, so we need the material on that surface by thin layer, multi-layer coating. Again, that one also we call as for thin film, people call as the composites, etc. Now, coming to the energy storage or renewable energy industry, actually always we need a clean, green, renewable technology. Again, the idea is that, so for example, the major source, like places like India, we have huge amount of solar energy. They are one of the viable source. Again, the places like, for example, in Canada here, there is a lot of hydro, which is water-based hydroelectric dams that mostly commonly used here. And again, the place like especially France and Japan, nuclear is also one. And also India also we have some thermal energy station, etc. Again, we have other things like wind and few other type of the renewables, etc. Now coming to the batteries, what are the importance of the batteries? As you can see clearly, if you talk about any major cities, for example, 40 to 50% of the pollution is coming from the four-wheelers. That's why people are looking about to replace to gasoline-based vehicles with the batteries. So idea is that the electric vehicles, again, that are very, it won't emit further CO2 emission, etc. Now, if we talk about this particular area, again, we talk energy, environmental science, and it is interdisciplinary. Sometimes we talk about the energy storage is interdisciplinary. We have to work with the basic sciences. Again, for example, if once your device is ready, you want to integrate, you talk with the mechanical engineers and automobile engineering. And again, suppose you want to understand the smart battery management or smart charging or battery safety BMS, and we need to talk with the electrical engineers. And information engineering play an important role. For example, if you work with autonomous electric vehicles, you talk with the electrical computer engineers, since these are all they work with uh, AI, and then a lot of engineering is science, information engineering is happening. For example, if you work with the material mining, then we have to work with civil engineer and chemical engineering. And at the end, we have to work with the management. So it is really very, so clearly shows that it is a multidisciplinary area. Now coming to the global, I think previous, I think today as people have been, I'm not sure they've been covered with this particular slide. Again, it clearly shows that there is a huge demand, but there is a global estimate. As you can see, the requirement is rising worldwide. Now, as you can see clearly, mainly in terms of fabrication and material mining, the China is dominated now, picking up all over the world, the thing, including that India and also America, etc. I think mainly now issue is that people are always talking about sustainability and then critical material. They not don't want to depend on any like sustainability. People are always talking about this particular area. So these are the different type of investment. As you can see, the North American electrical vehicle industry. As you can see, not only I'm talking about these startups and then big car manufacturers. As you can see clearly, there is a huge investment in these particular things. Parallelly, again we do with academic university. Again, we don't. So that is a little bit in a smaller scale, real applications. This is the way people are concentrating this area. And these are the few investment in Quebec, so industry also in Canada and few other part of the provinces. Now, what is the importance of energy storage? I think as you can see clearly, so always I think the price due to the price of crude oil prices rising as a consequence, the gasoline prices to rise. Another concern is that in addition to this one, there is a major concern is the CO2 emission. Due to the CO2 emission, there is a lot of climate change and people have health issues, especially that will lead that, especially in terms of long term. As you can see clearly, I think people are, especially environmentalists, are concerned about the CO2 emissions that will lead to the unpredictable rain and rise of temperature, etc. So now coming to the batteries, what are the major problem? Because if you go for smart grid or plug-in electric vehicles, we need something like a megawatt to kilowatt range. Automatically, we need more amount of raw materials. So that is really, and so these raw materials we have to locally we have to produce in any countries. So we don't want to depend on the other, for example, China or North America, etc. So idea here is that so you want to be self. It's not like 1 gram. It is tons of few thousand tons per year is needed to require, for example. So again, the lot of material is needed. So that's why sustainable people have to produce large scale manufacturing locally. So especially mining and etc. is needed to fulfill the any country's requirement in the electric vehicles. Now, again, I mentioned that the impact of CO2, the slowly rise of temperature. So that's why it is also another concern by environmentalists. I think some people IC versus EV. So I think this is a slide I collected some of the from literature. As you can see clearly, all the cases there is a small emission of the CO2. In fact, I can tell that you not to fabricate for solar photovoltaic cells. Also, especially in terms of fabrication side or mining, battery material manufacturing. Again, we limit the small CO2 emission also because overall we compare it with other things, other type of energies, at least we can reduce a lesser CO2 emission when compared to the other type of the energy, for example, coal and fuel, gas plant, etc. So now coming to the battery component, in fact, now I'm going to a little bit touch up the top topic. So at least here the real term composite will come. For example, so here the cathodes we see this cathode means usually layer type lithium cobalt oxide. If we work with lithium containing compounds or iron phosphate, so these are the well-known cathode materials. So these are the ceramic material. The ceramic material it won't stick on this current collector because we need something like a binder. Either we need something like PVDF polyvinyl difluoride is a binder. So this is the one so, and some conducting carbon to improve the electronic conductivity. So that's why we call as a, in these cathodes, we call as a carbon-based, for example, cathode composite. Other side is the anode. So usually we use the graphite for commercial cells, either naturally or artificially. And sometimes we may use some iron metal oxide, although practically real applications, the graphite is one of popular thing. And what center is the separator, this is a polymer separator. This again is a porous polymer membrane. So it will enter the either lithium or any type of iron, sodium or potassium ions go in and enter. So it has to, this is the objective of this one. In between, we use something like electrolytes. So it is usually a liquid electrolyte, LiPF6, CDMC. Sometimes we may use ionic liquid and polymer composite and solid electrolyte, etc. I'm going to touch up in the later all the terminology. So again, I think these are the terms. Sometimes we may use something like oxidation if you are basic sciences people, or if you are mechanical or electrical engineer, we call it the state of charge, the DOC, discharge. These are the terms we use in, for example, charging or discharging protocols. These are the terms we will use in this particular thing. Now, coming to the what are the composite? For example, here usually nano composite or composite always we work with the metal oxide. For example, you can see the top there is a some ceramic powders. From there we use something like some super P carbon or binder or CMC or carbon if it's a graphite they use, and then finally so typically you can see this is called as a composite. Finally we're going to coat it on the either copper or aluminum foil in order to make a thin coating, for example, around 100 micrometer or 120 micrometer, depending on the thickness requirement, they can coat. So usually, and sometimes the polymer we use, I use the term nanocomposite for electrolyte, sometimes solid electrolyte, polymer electrolyte. Again, these are all the similar terms. Now, typically, once you coat this particular in a battery, it is a large scale. This typically exactly you work with the commercial battery. Again, always looks like this way. Again, so typically once you coat this, for example, binder and conducting carbon and your ceramic powder, then finally look like that way. So in order to make a good addition, we need to do further calendaring. For example, here we use something like a roller For example, if you work with the mechanical engineer, they will use something like hard pressing, to like spark plug sintering, and then different type of the metallurgical approach they use. I'm going to explain the later how if it is a real ceramic or alloys, super alloys, or they want to composite alloys, they want to use some other technique. Here, since these are the graphite, and then these depending on these materials are easy to press it, calendar it, and we use this particular calendaring unit in order to. So finally, after calendaring, it looks like this way. It is very very important. Now people may ask you why. So this is contact between the current collector and the active material is very very important. Means good mechanical properties. Here, mm, for example, due to this one, so there is a nice electronic conductivity. Also, the current collector to the active materials that will lead it to really ions want to uh, insert and extract. It will be very easier. So now this is a typical another the schematic diagram. How composite materials for the cathode or anode we can fabricate. Again, typically you took the active material conducting carbon and binder either in a small beaker or in a laboratory scale, or you want to do it in a same ton scale, for example, 10 tons or nearly 1 ton, 2 tons of the quantity also. All gigafactory the people can do is automated. And finally, they coat it on this particular doctor blade. Again, the thickness you can, for example, 100 micrometer thickness, you can coat it, and whichever thickness you want, you can do. Finally, dry the thing. Then again, we have to pass in a roller. Either, for example, in a small button cell, coin cell you can do, or you want to be pulse cell or cylindrical cell. Again, the story is same. So usually, different type of the processing again, either in a dry room or in a glove box. People they can fabricate the cell. Typically, how it will work in a large scale industrial manufacturing. Exactly same story. Here the quantity is nearly tons, so the quantity nearly they will take 1 ton or 2 ton like quantity the large scale or few 500 grams kilograms the quantity they use. And once the slurry is ready, everything is automated. They do drying and calendaring again. This online in-house all automatic gigafactory they can do. Finally, they do calendaring. Calendaring purpose is that in order to make a good addition. And finally, they cut the electrode. Everything is automated. Whatever the shapes they want to do, and finally stacking and welding, and then finally filling the electrolyte. Again, everything is automated. This is the way usually they do in automotive manufacturing. Again, although in a laboratory it's very difficult to because of the available facilities. Still, I think this type of things people can use. I think. Now, a little bit more clear what I'm going to summarize. So, what way I talked about the composite material, composite in the terms of my energy storage. Again, I told I've used something like a PVDF. So, in the polyvinylidene difluoride, so that are used in the cathode materials. So again, the CMC carboxy methyl cellulose and styrene butadiene rubber. So this is also used as a binder for the anode, including graphite, in order to use this one as a binder. So idea is that so since my first previously first presentation I've been already talked about what are the importance of the composite. Usually, mainly here also improve the mechanical properties and good addition of the cathode and anode active material on the surface of the conductor. This is the main objective of this particular composite. People may ask you that no, I don't need any binder without anything like lithium cobalt oxide, graphite. You can do it really difficult because the addition of this one really due to this particular composite material. That's why the terminology these composites are really we although we don't have good cathodes, we don't have any proper binder, we don't have that is a composite material, it will not work. And another terminology, I think yesterday my I think previous or people have been talking about importance of carbon graphene with the various applications. Again, among them, I think graphite, I think is one of the important material that is used in the energy storage. Again, so here we use something like either cathode anode, we mix with the super P carbon or carbon fiber, CNT or graphene as a nanocomposite to improve the electronic conductivity. Especially people are looking about the fast charging. For that case, this is really very important. So I think the taking to this consideration, these I think these are the important points, and maybe what I will do is that later next time the few example, and we use some this particular terminology, and for real applications, I'm going to explain in this next maybe another uh, 50 minutes. So what are the important, I think again the battery materials, I think the 2019 Nobel Prize is given with battery, again the one of the Professor Chan Goodenough. He's also Department of Mechanical Engineering, Texas, as well as a chemist and physicist. He worked on this extensive work more than, I think after almost 50 years of research, finally they won the Nobel Prize. So now people may ask you how Nobel Prize, again, it is not coming from industry. Again, it is coming from the academic institution. For example, classes like colleges like Elite or universities in Calcutta, etc. Again, so the story here is that all we need dedications and new ideas is very important. I exchange, sometimes you have to go to the some ex laboratory, there is the way this FTP or conferences, at least you are giving the contact thing, that will be really very useful. For example, Professor John Goodenough visited my previous laboratory at France where I did my PhD at the time. So these are one of the well-known solid state chemistry laboratory. At the time, the people always they're concentrated, they're working on something like superconducting properties of this and physical properties. So they like sodium cobalt oxide is existing in the long time. It's not like a new olden times. The sodium based batteries are existing. I mean, due to the stability, people are not using the battery applications. So what Professor Kudanap, he replaced with the sodium by lithium, and then he discovered the lithium cobalt oxide, and he published in a small, it is not a hi-fi science or nature, it with a small impact factor, 1 or 2, or at that time is a material research bulletin. So then took their idea, the Sony, and then finally commercialized with this particular material. Now you can see there is a huge battery industry, including the electric vehicles. There is a lot of advancement is also happening based on this particular cathodes. And again, there is a lot of further advancement is happening with about solid solutions and iron phosphate, etc. So now coming to the little bit more detail. So once I told you that once your composite ready, so either this composite, you put it in a small pouch cell, this type of cell, and or you want to run with a cylindrical cell. This is like 18650 means 18 mm, 65 mm. This like 650 mm. This particular length of this particular cell. Always remember that this particular, for example, you want to with the laptops, you may use a smaller number of cells, or you want to run with electric vehicles, you may allow assuming that this particular 1850 cell, they put it in the particular this modular case like that. For example, you can see modular case, and then finally, always keep in mind that typically your electrical vehicle are packed with. Then one can imagine how many number of cells, nearly 7,100 cells. They're going to put it in this particular pack, and then finally, the bottom you can see that the electric vehicle are packed look like that way. So so again, the issue is that here they cut a lot of electrical engineering people want to understand the how the battery, how to the smart charging battery management system. Again, the for example, sometimes it may catch fire due to the SARS, and there is issues with the charging protocol. Again, there is a lot of we have to do interdisciplinary work, and for sometimes you have to integrate this battery into the like car again. That's why the real automobile engineering and electrical engineering will come in the picture. Now again, the typically I already mentioned that 18 mm, 65 mm, the length, this particular this type of cells are used in this particular typical Tesla or any electric vehicle or car like this way. So already I mentioned that we use something like lithium, nickel, cobalt oxide. I'm going to discuss about what are the important cathode and anode composites are used in this particular battery materials. Again, the now issue is that presently with the battery voltage is like this way are now issue is that the weight everything is like fixed, because only way is that we won't reduce the number of cell. Only way is to do the lot of advancement. New material discovery is needed, means that doubling the energy density we need. So that I'm going to discuss about what is the energy density or power density in the coming slide. So, as an academic point of view, so it is a lot of opportunities. People have looked for new material, doubling the energy density is really good. So, in terms of engineering, especially mechanical engineering point of view, a lot of industries, people are focusing about the cell manufacturing, there is a lot of advancement is happening because each industry there is a lot of in-house, there is a lot of competition with their own internal IPs also happening, especially that's because they view the in terms of manufacturing side, especially cell manufacturing, a lot of things. So it is like really their own IPs is happening in this particular area. Now coming to this a little bit more simple, I think all people are know that it is like electrochemical device. It convert chemical energy into electrical energy. Typically, I mentioned the cathode, anode, and electrolyte material. During charge, what will happens? The lithium ion from move from the, for example, the cathode lithium cobalt oxide. So it moved from lithium move from cathode to anode, where the electron will pass to a circuit. During discharge, again the reverse reaction is occurring. So again, lithium will go back to the work. That's why we call it the rechargeable battery. That's why. So typically, when you remove the lithium, so for example, voltage versus potential, so we can get so we can produce a voltage, develop a voltage. This is called a plot potential. Again, typically the voltage, the galvanostatic plot means at constant current. The voltage versus capacitors, you can see clearly. Cathode must show the higher charge potential. For example, you can see clearly so higher charge potential is very important. So always keep in mind that, for example, so if you want to design a new cathode, always you look into mind that higher charge potential is very important. Anode should be lower discharge potential is really important. The difference between top when it's charged when it discharge potential is the energy, voltage of the cells multiplied by the capacity give the energy density. Same thing. Another way is want to multiply current we call it the power density. So this is a very important point you take into consideration in order to design a new materials. Again, although we have to consider into the low atomic weight because atomic weight is that will determine, for example, the way your prepared new material is higher atomic weight, automatically we can get a lower energy density. And ideal material means cathodes must deliver the higher charge potentials. This is very, very important. Anode deliver lower discharge potential. Again, energy density is nothing but voltage in itself. Again, it will vary depending on the cathode anode. For example, I may ask you which is the among the top one, two, three, four. Top three cathodes means a lithium iridium fluorophosphate has higher energy, expected higher energy density because of the higher the voltage multiplied by capacity, you will get higher voltage. So that's why. So that will leads to the higher energy density. I'm going to touch up in the real applications with a few other things. And another important point you take into consideration, electrolyte must not soluble with electrolytes, either cathode or anode material. And also is very important you have to take into consideration of the mixed ionic conductivity means so for example we can't use any insulating material, so material should be mixed ion conductor. That's why people they use some carbon coating to this one. Now coming to this, what are the important points? For example, you want a smart batteries or again or energy thing always again this is comes to the real picture because always when I buy a battery pack, since I'm engineer, I'm an electric automobile engineer, you don't care because I always I buy the battery pack from the manufacturer, from battery cell fabricator. So always when I integrated this particular into my electric vehicles, always it has to adapt the climate conditions. For example, if for example the place like here in Quebec, sometimes it in Canada, some part of the places it sometimes it may go to the -40. Sometimes in places like India, sometimes in summer and few other places, it will go to the high temperature 60. So it is batteries to must work with high and low temperature. This is very, very important. That's why in some cases, depending on the climate conditions, people so they use something like either again the I'm going to discuss about the cooling system again the depending on the climate condition, depending on the battery pack, etc. And long life cycle life and a long cycle life is very important. More reliability in the sense once I promise if I for example if I buy a battery pack still for example 10 years will come without any problems still is really good. And for example, long life, for example, once you told that 360 kilometer for charging it must test to work. So it is very, very important. And high energy density, and this is a lightweight is of very characteristics. Coulomb efficiency is very important one means I would get initial cycling efficiency above 95% is really 94 is good. Resistance to the cell is minimal because this is a way as an electrical engineer will decide the battery is good or not. It means that during long-term cycling, the resistance should be minimal. For example, on a battery pack, it is a 5 ohms. So after 5 years, it is going to be 50 or 10 ohms is fine. It is going to be 5,000 ohms or 50,000 ohms, something wrong with the battery pack. So this is really, it will tell the impedance of the cell, it will tell the state of the health of the battery. Fast charging is one of the things I'm going to touch up this particular thing. What are the importance of the fast charging? As you can see clearly, so after solving all this one at the end, the commoner or any other people always they look for safety, and cost is very very important because they want it by it's a reasonably low cost is good, and no toxicity at the end. Once you reach a material should be no toxicity, don't and sustainability and recycling is really really important. Means after for example 10 years, so we huge amount of wastage and generating at the end you have to recover, and recycling is very 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 important for this particular. So another important point I already mentioned that now people concerned is that because, for example, I fill a gasoline vehicle, for example, within 2 minutes, 3 minutes I can fill. Is there any way to I can charge a battery within 2 minutes, 3 minutes, or 6 minutes? As you can see, yes, is possible. We have chargers are there. The main issue is that if you go for higher current rates, for example, 6 minutes charging the capacity reducing, the mainly due to the all material may not be participating the electrochemical cycling. So as a also there is a issues with the graphite. There is a lithium dendrite plating will occur. So, and as a consequence, in order to buy any battery pack, they use a something like their own protocol. For example, 1 or 2 hours like that. So in order to retain a maximum capacity, and also lifelong because safety aspect is also very important. So, and also there is a lot of, for example, nowadays, I think depending on the, the recent technology, because of the fast charging applications, people have designed the new materials such a way that, they may reduce the shapes so that in order to get uh, desired applications. For example, fast charging, they may look for the materials in a different, fabricate in a different way. For the normal applications, they use it so that or you want to with electric smart grid, there again there is a different requirement accordingly depending on the application. People can fabricate in the material manufacturing according to the customer, the fabricator requirement. The large scale industry they do they fabricate the material accordingly. So in summary, why the lithium battery are popular, mainly lightweight and design. So also we can use that the acid again, mainly the voltage is limited. So if you do the nickel can, for example, other one, so again the mainly lightweight and energy. That's why you can use it with the various applications. Now coming to the real, what are the important, for example, already I mentioned that in order to sustainable for any countries, I think we need a critical mineral is very, very necessary, is very important. Mining and processing of the any material is very important. From that to battery category, either you want to be lithium, nickel, manganese, cobalt, iron, phosphorus. These are very important materials that are used in the cathode and electrolyte fabrications. And for example, anyway, sodium also we need it, so that one is a lot, plenty of sources, and not issue. Graphite, either you can produce with petroleum pitch, either in artificial way. Means again the disadvantage here is we need nearly above 3000 high temperature processing. Again, we need a lot of energy. To another way is the natural. So naturally occurring the rocks where we presently, so we people are doing the R&D in this particular area. So again, the naturally here for example, natural rocks, we have to extract them almost 5%, to purify them, shaping and coating. It is all same for the either artificial or natural thing. So again, the purifications again, so another step is happening with respect to natural graphite technology. Copper, steel, and cell pack and manufacturing example. Again, the polymers are separators, neodymium, dysprosium, they are used in permanent magnets. Again, the you want to be, for example, electric motors, we need something like silicon carbide for the EVs. Again, these are also used in, so that's why we need, these are all important materials are needed for the requirement of the large scale manufacturing of the electric vehicles. Afterwards, once you get the, because these are the main criteria, if you have this particular thing, people, industry, they can process it, the minerals are there, they can process it. Accordingly, you want to prepare, for example, lithium, cobalt, or nickel. Again, what are the cathode people want to do, they manufacture, they can prepare. Once the materials are ready, they can fabricate, they can supply in a cell manufacturers. So I think they will do. Again, I already mentioned that automatic systems are there, they can do in a small scale, large scale. Again, the according to the requirement, they can R&D, they can check, and finally sell back and manufacturing once it is done. So either they can, for example, people want to use it for the EV or a smart grid. Again, the different for example, car manufacturer, they buy the requirement. Or for example, people want to with a small grid. Again, there is another different type of big another industry. So it is a way different the people are working. Or you want a small scale in a power cell or and for the portable applications or iPhones, etc. Again, the manufacturing technology is same only thing depending on the requirement, depending on the applications people can use. Again, after 5 to 10 years, 10 years, we have to reuse them. Either way is that we can use it for the secondary applications like home, etc. And at the end, if it is still life cycle, because we can't throw the battery, we have to recover, reuse the battery in a particular, and again you have to recover the materials. There is a way of circular economy to work. Now, people may ask you that why cobalt-based batteries are expensive than olden times now. So you talk about the mining cost, the 30 tons of the mineral give 30 kilogram cobalt, whereas the nickel-based 5 tons gives 60 kilogram. Automatically, nickel mining. So that's why people have any countries a lot of nickel resources, nickel mining. So that's why they replace the cobalt and partially. So and they can use and then automatically they can reduce the cost. Again, so that's why if you talk about the battery manufacturing is concerned mainly dominated by China presently and followed by still anyway in India also picking up so this particular thing. See, this number is the old one still, but I'm telling that in order to be sustainable, again, any countries they have to depend on themselves, so we don't want to depend on the some X country to send the sample. So there's a way here in a graphite, so that's why they incubate. There are a lot of natural graphite, so they're extracting so to supply in North America, especially America, or Europe, etc. So now coming to the already I mentioned this particular important point. The electrolyte is the one I told you, the inorganic, either you want a lithium-based salt or sodium, or you want to use another type of like a zinc battery. Again, all we need respective salts are needed. So either highly ionic salts, and sometimes you may use something like organic carbonates, and reasonably kind of good conductivity and wettability is good. Another one is a solid lithium polymer, solid electrolyte, we call it the composite. Again, the reason is we use something like a polymer, PVDF, HEF, the polymer salt, and some filler they use to not. So this type of advantage of this polymer based things is that we don't have any leakage issues, and electrolyte operates reasonably good temperature. So another, again, I'm telling that this, I don't have much time to discuss again. We use something like a binder, PVDF, and electrolyte. So these each because so have their own advantage. Again, we need a lithium containing salts are needed to the mine's lithium source, and we need a salt again under with respect to the. So this is a typically the polymer electrolyte, and so if you talk about the polymer membranes, but because again you can see these also we call as the membranes, polymer membrane based composite. Again, either in a laboratory, in a small scale, bigger, you can do finally put in a petri dish and dry the things, and they can do if it is lithium based system. People have to be glove box is good, so in order to avoid the further reaction with the lithium salt with the air. So polymer separators, again, which I already mentioned, provide the short circuit we use. Again, so it is very important point. Thickness is less than the 25 micrometer. Porosity and good permeability and good tensile strength is really very important, because sometimes the puncturing of the separators and weightability is really very good. So this is all the things, the characteristics of the separators are very important. So what are the importance of the, for example, another is the solid composite electrodes. So, so what are the important points you have to always you to remember is that just I'm timing how much time is in India, so that at least I wanted to. Okay, so so it is very very important to understand. For example, solid electrolyte. For example, here also we call it the composite electrode. Here we use something like, for example, spark plasma sintering or hot pressing to not to make a ceramic composite. Again, although there is a lot of advancement in this particular, still there is a lot of challenges in order to fabricate in a large scale roll to roll processing. Still, a lot of industries are spending because of the this particular technology. Here, I think we use something like hot press and spark plasma sintering techniques are used to, since these are the ceramic based system. So again, I think I don't want to touch up so many things. Sometimes sulfide based materials also there, some oxide weighted materials. Each materials have their own advantage, disadvantage in the handling, etc. People may ask what are the applications. For example, people wants to be aqueous air batteries or redox flow batteries or all state batteries. Again, the solid composite materials play an important role in this particular applications. Now, quickly, I'll go through material fabrication care. So, since I don't have much, I'll try to touch quickly some briefly, since my previous speaker already been talked about this particular area. Again, as you know that here the mechanical, some people are working with alloys, they may concentrate on the particular elements. Again, where the batteries, we need something like lithium, nickel, cobalt, and phosphorus. These are the important materials in the material in the battery fabrication. Again, so the typical things, all the typical research we do, depending on what applications we're looking accordingly. For example, if we're mechanical engineers, we try to, for them, the mechanical properties are very important. For example, and sometimes people look with electrical properties. Again, and depending on what type of applications, identify the right candidate. It's not like all material, one material to solve all purpose. It is not possible. So we have to understand the structure composition. I want to be nano and submicron size. And again, we need appropriate processing. So it's not like one particular technique will solve all the problem. Not really true. So we need appropriate processing. And finally, we have to, again, the characterization play an important role in these particular things. Again, sometimes in nano and submicron size, again, the depending on the terminology, sometimes. So because this nanomaterials leads to high surface to volume ratio, sometimes depending on the improved properties, sometimes filling properties, etc. At least if you want to be composite, nano composites or ceramics also, people they told if you work with the nano composite with submicron size materials, then finally they can get a good mechanical properties, etc. So typically, I think these are a laboratory in a small scale. People can already demonstrate what type of size and shapes is possible. Again, it is particular to the applications. So the story here is that either you want to be chemical methods. So these are the in a laboratory scale. That likely we have been developed in the small scale, and again the industry is concerned. For example, co-precipitation these are the hydrothermal method including China. A lot of manufacturer people are producing a large scale manufacturing of this particular thing. Already people have been developed. So the reason why I'm mentioning that this is for large scale, so people they always the manufacturing criteria is different, the processing of the materials, and they want to be simple steps. Make sure that they won't emit for too much steps, so that at least we can reduce the cost, and then method should be very simple. So another important point you have to remember again the physical properties. Again, thin films. Sometimes we may use something like nano coating. For that case, we may use something like PLD, atomic layer depositions. Again, so in order to coat the surfaces or the materials, for example, people they use something. Again, the plasma and CVD. Again, these are all the techniques. People in I don't have much time to discuss in more detail. Again, the sputtering. Sometimes do some nano coating on the thin films, etc. Again, for example, in order to make a, this is a, for example, densification of ceramic and composite. Again, are composite materials. People, they use something like a powder metallurgy techniques, for example, injection molding, hard pressing, these are the particular techniques I think people have been already previously people have been talked about. And additive manufacturing like 3D printing, etc. spark plasma sintering. Again, they use these particular techniques to get a because it's especially the mechanical properties, for example, for them is the good mechanical properties is really that will determines their application. For example, the cost for the particular thing they look for how the for any composite material mechanical for them is they need appropriate technique. Again, applications, I'm telling that solid oxide, solid bed alloys, and super, again, including the car manufacturing, again, composite, etc. In a few other applications, they use this particular technique. Quickly, I'll go through because thin films, again, this is also we call it the composite, again, the layer by layer growth. So sometimes this is also one way, thin film terminology is thin film composite, because they use layer by layer growth depending on the applications. And again, in general, thin films will be quite different from the bulk material because of the anyway. Idea here is that depending on the applications, they need a proper dimension, good mechanical and physical proper, especially the plasmonic applications. They look for the particular shapes, etc. Again, for thin films, again we can try that we want to become CVD and different type of techniques people can use, or you want to be integrated circuits. We need ALD atomic layer or pulse laser deposition. Always is very important depending on the applications. Optimization of thickness is very important. Composition, understanding the surface and interfacial effect and mechanical properties. It's very, very important for the real applications. Now, once you do this one, I think my previous speak already we will have been talked. I don't need to discuss too much details. Again, we would characterize them. X-ray is also one of the very useful tool to understand this one, and especially for thin films, we need a Rutherford backscattering spectroscopy and microscopy analysis, and batteries, we need a potential static galvanostat, and we need a some mechanical analyzer to evaluate the really, and few other impedance analyzer and few other techniques. And we need appropriate software to understand, and a lot of especially the material simulations. People also we work something like material, especially on different type of software. People have been already adapted for the. So why I'm mentioning that when at the time I'm talking more than 25 years back on really XRD or almost not a good readwell refinement. I used to collect take more than 24 hours. Now due to the advancement of the technology, we within 5 to 10 minutes we can collect the data clearly thanks to the uh, instrumentation and detector technology. Now coming to the quickly only XRD, I think already people have been touched up. I don't need to discuss too much details. Again, the X-ray is one of the useful tool. For example, you want to be amorphous or polycrystalline. For example, sometimes they may use some polymer composite or metals. So they use sometimes too much polymer membranes and slight weight materials. Sometimes you may not see. So you may get something like a broad lines clearly indicate this amorphous, some nanocomposite, etc. Suppose, for example, if it is ceramic material, unmarked, if you do the TEM, transmission electron microscope, so there with the XRD, we can compare if it is a polycrystalline or nano and amorphous. So depending on the rings, the people can compare. So typically, for example, what we are getting the d-spacing obtained from this particular values, and what the ring inner ring corresponds to the diameter divided by 2, then 1 over d it gives the this d value close to what we are getting from XRD. That is why usually TEM microscopy, TEM people, and then X-ray, they can complement this particular any analysis of the material. Especially for thin films, again, if you want to do layer by layer growth, we need something like cathode anode electrolyte separator. So this is really, and especially glow box is needed to not to make a, also like since it is a lithium containing sample, they're air sensitive. So we have to work together. So I think I have another 20 minutes, another 10 minutes by question. And so quickly I'll go through what are the important points you have to take into consideration. Again, if you want to micro batteries, all this one have been already demonstrated. So, for example, small electrochromic devices, if you do inorganic oxide coated on the ITO substrate or polymer, again, especially they use it for the smart display and various other applications. Now, quickly, I'll go through again. I'm telling that if you talk about electric vehicles, again, hybrid, the key component is, for example, as you can see, we need a power electronics, electrical machines, and energy management. So it is really, it is interdisciplinary. We have to all people, you have to work together. Now, For example, the battery management challenges, since so many cells, we put it in the particular battery packs. So sometimes all cell must uniformly has to charge. It may not over discharge the individual cell. So this is really very important. For example, what we call as BMS management will do. I'm quickly I'll tell that. So you can see clearly. So for example, so many cells the battery charge are doing. For example, you see the left side is really good because all the cells are uniformly charging. So this is very important sometimes. So this particular things is two cell two cells are good. Again, you can see other one is not good. So good battery management, charging protocols means all the cells must go to uniformly. So that's why the electrical engineers must work in this particular category. Again, importance of wide band gap devices for EV applications, as you can see clearly, the importance of silicon carbide. Again, especially for EV charger and gallium nitride also people are using. So again, so these are the different type of the hybrid type of the things are used in the electric vehicles. So now coming to the composite electrode material. Now again the case studies I'm going to discuss. Again the few maybe 2-3 examples I'm going to discuss in the cathodes and anodes one or two examples. So that will be good for the okay. So overall summary that intermaterial synthesis is good. Surface coating people have been already demonstrated in terms of the engineering point of view. The cell manufacturing, a lot of advancement is happening. What they do is that they take a well-known commercially available cathode material. Although I discussed so many materials, among the top 2 to 3, 4 materials are using for real applications. These are the layered based on lithium cobalt oxide. I told you that nickel, manganese, cobalt. This means 80% of nickel, 10% of the cobalt, manganese, cobalt, etc. These are the solid solutions. The idea is that to reduce the cost, they're replaced by cobalt by nickel and manganese containing compound. Always keep in mind that so we need to be potential should be low. This is the requirement for the your electric vehicle or energy density. And again, we have something like iron phosphate, lithium iridium fluorophosphate. I'm going to touch up some few examples what we do in our work. And graphite is a very popular one because of the lower potentials and reasonably good capacity. So as you can see, cathodes are few, graphite is reasonably good for the anode side. So these are one example. Again, I told you the lithium iron phosphate. Again, so these are typically the discharge potential, and people are use it for the carbon coated sample for fast charging applications. Coming to the layered cathodes, for example, lithium nickel with the various solids that are in the electric vehicles. Again, there is a lot of advancement with this. Although it's the same materials, people have been producing different voltage variations to not to get a maximum capacity and then long-term cycling. So as you can see, the NMC means in lithium nickel over demand. As you can see, there is a huge demand with respect to the over year because of the uh, electric vehicle or especially needing more raw materials. So typically, I'll already discuss again the composite electrode materials. Been the steps already discussed. This routine same way, active material finally coat it, and then finally the cells are ready. They can test it. So either you want to do it in a large scale manufacturing, the similar way they do. So again, the manufacturing side is concerned. The people I told you that we either want to be cylindrical cells or different type of cells. People are working on this particular area. Composite already I discussed this the way it will work, and typically, if you want the cell is ready, they put a bottom cap. Again, your material separator, lithium, either graphite. Then again, the bottom cell is ready. Usually, there's a way do it in any gigafactory. They do in a small button cell once the performance is good. They go for pouch cell, cylindrical cell, etc. They can do. We need a potentiostat, galvanostat, and then there's impedance analyzer. So this one particular example is the lithium iridium fluorophosphate. So always keep in mind that here vanadium redox couple, the 3+ to 4+, reasonably good capacity. So in terms of thermal stability, I told you that this is really good when compared to the lithium cobalt oxide. Again, we try to prepare for some nitro carbothermal reduction method. Here, carbon act as reducing agent. So typically, in this approach, we've been worked with the various, not only this particular material, various inorganic, some oxides and metal composites have been produced. I think this technique is very useful. I think this is similar technique what they used for the iron industry. They use a charcoal or graphite to reduce the iron oxide to iron metal. Exactly the same story. When you need a high temperature, etc. So typically you get a 4.2 volt cathode material. I told you that there is a VPO4 LIF, finally 700 degree, 1 hour and argon. So the X-ray is the one to tell the single phase material. We characterize them, make sure that they reasonably and fabricate them. And then finally the similar button cell approach. Typically, as you can see clearly, these are charge and discharge potentials and reasonably good, nearly 6 months. It means the long-term stability is really good. So as you can see clearly, when nearly 4.2 volt cathode we can get. So you compare to other three type of cathodes, top lithium vanadium fluorophosphate has higher energy density expecting because of the higher voltage. I'm talking about this is in 2010. We worked at the time. People always think that it is very vanadium is expensive. Story. Recently, I think last year I was at Germany for the battery conference and advanced. So there, the French company called SAP is one of the best fabricator the battery cells. They recently commercialized these particular materials for the large scale applications for the specific applications. For them, is the cost is very important for the especially for the large scale application, they're looking for the good energy density. Anyway, as academically, you can do the in situ or ex situ XRD, and we can do impedance analysis for this, understand how the transport mechanism, etc. Quickly, I'll go through lithium. Yes, what is the another things? If you talk about the C, the 6.9. So if you go for ionic radius, the mobility issues means cationic radius is higher. Also, as a consequence, you can see slightly lower reduction potentials. So these are the again the same story. Another class of the sodium-based system. As you can see clearly, these are left side is a lithium-based system. As you can see, vanadium as a 4.2 volt. Again, the same materials I prepared in nearly 3.5. So a little bit lower energy density. That's why presently still maybe another 5 to 10 years, still lithium is more popular. Later, once the sodium technology is matured, they may again they for them is only change the material. So that is the way that presently the battery car manufacturer is working. Now again, I think 2019 2025 Nobel Prize has been, I think, metal organic framework that are used in the various applications, including that various. So I think I'm telling that in this at the time we try to prepare some vanadium based. The first example in the vanadium metal organic inorganic based example we've been reported for the first time in at the time is 2012. We started at the time is so our idea is that look for the higher voltage. So nearly when I compare to lithium iron phosphate, nearly 4.15 volts we are getting, so reasonably good voltage. So again, we try to prepare the sample with a simple approach. So we try to with a simple magnetic plate hard plate stirring is so only issue is the water. We have to get rid of the water. We need to nearly heat sample to 150 degree to remove the things. Again, the story here is that so we can characterize them. And the capacity wise, a little bit limited, and nearly another 110 is getting. So anyway, for the practical applications, the people, so we don't replace this particular material, but tomorrow because they need something like above 150 is good for the real applications. Anyway, I'm telling this is academic research. I'm telling so again we can do the sodium with the potassium ion batteries. Also, we can do again the issue is the energy density capacity is lower when compared to lithium or sodium-based batteries. So we worked some other thing, vanadium compounds at the time. So I was almost early work. So based on our early report, finally people have been, including novel R8s and few other people have been reproduced and they've explored the same materials in a different fabrication techniques. Idea is that this is academic research. People they can do depending on the things. So quickly, I think I'll go through since another part of this one is the anode-based materials. Again, the Mainly, I'm touch up with the graphite. Again, this way the graphite is because since it's a very popular materials, people want to use in a lubricant, paint industry, refractive materials, graphite crucible, high temperature gaskets are used in the special automobile industry. So again, the fuel cell sensor, again, what CO2 storage, again, the capture and energy storage and application. In fact, there's a lot of applications, graphite, graphene. I think yesterday, my other speaker have been touch up this one. So specifically, I'm focusing on energy storage. You may use graphite. This is the things, the typical potential of graphite. Graphene, the bottom two graphs, as you can see, although we get some high capacity, practically this may not be really useful. If it's graphene alone, we can't replace the graphite. So that's why they may use something like graphene additives, means small amount of graphene is improve the electron, not the graphene alone replace the graphite, is not possible, because mainly due to the lower uh, voltage hysteresis is the major issue. So quickly, I will go through since I don't have much time. So again, a lot of efforts have been done. So academic research is concerned because the tin-based alloys have been already. So although these are more on academic than not like all the material people are using for tomorrow to replace the industry. Still, as academic research, these are few examples we've been in first time we've been reported in the literature. Still, there is the challenges here. So again, the irreversible capacity in the first cycle is a major hurdle for the for practical application. Similarly, here the voltage is difference in charge and discharge potential is so there is a little bit big issue in this for the practical applications. That's why, although academically we can do still, so there is a interest in this particular things. Again, we talk about the sodium versus lithium. Sodium compounds anodes wise is a little bit lower discharge potentials. So again, another bunch of material. Again, the LTO is a top discharge potential that may be really good for the practical applications. Other one may not be really good for the I think I'll go through the TiO2. I don't have much time. Then again, the TiO2 is one of the well-known materials are used in the multifunctional application, coating or solar cells, or including batteries they use. So either you want to prepare in a small molten salt approach with ice. Here, typically we demonstrate go to nano size to micron size how the lithium storage behavior. As you can see, the top one is a higher surface area. Again, accordingly, we can see the battery performance is different when compared to the crystalline materials, even lower performance when compared to the nano size materials. Again, the story we can use it in the DSSC for the applications. So similarly, another supercapacitor, again, the story is the same. Again, that's terminology. Well, for example, battery composite people are using. So my time is almost another 5 to 10 minutes. So quickly, I'll go through the what are the things about in terms of mechanical engineering point of view. So how the thermal runaway battery is occurring. So again, the issue is that sometimes battery is catching fire. That may be due to the. So it really contains the cathode separator anode. And really, our idea is that try to understand how to mitigate the things. For example, there is a fire, and what is the possible reason for the fire? Either we have to understand the failure mechanism of the batteries. Again, we have to see that either mechanical abuse, electrical abuse, or thermal abuse, and that will also lead to thermal runaway due to high temperature, dendritic growth, electrical abuse, deformation, or including separator again. So these are all the things are the very important one. In terms of the anode side, that's why they may due to the lithium dendrite formation to the fast charging. That's why that will lead to short circuit, and that's why during the fabrication or BMS protocol, they don't tell that do it very fastly due to the issues with the graphite side. Similarly, cathodes, the overcharging that we lead to thermal runaway, it means that cathode means electrolyte, exothermic reaction with electrolyte, it's oxygen release, and also sometimes slowly the lot of volume variation is occurring. So I'm going to touch up one example in this particular category. Similarly, electrolyte, so we can't use the high temperature. Similarly, separators, because these are the polymer, it will shrink, so we can't use this particular temperature. So now I think current collector is also very important as a system that anyway these are standard one people they use anode side always current collector is cathode side is aluminum one. So I think in order to avoid the fire safety, people are using some additives, and there are a lot of advancement in the electrolyte also, electrolyte additives. And again, in terms of manufacturing, people have been study the various approaches to see the and fabricate the cells, and then understand the different type of the, for example, how the post cell, for example, understand the mechanism. So, so for example, the puncturing test and then nail penetration test, etc. They do. So in summary, what is the importance of this particular? Again, yeah, as I told you that we need a thermal management, air cooling, liquid cooling. Again, here safety devices and also and fire control. Again, the battery fire. I think the casing and again battery casing itself. For example, if I talked yesterday, I was in the, I think last year I was in battery conference in WBC. People always battery casing itself the one big areas because there are a lot of composite materials, lightweight materials. Again, they can concentrate. Again, the safety vents, devices, circuits. Again, as you can see, although some basic science is involved here, again, a lot of engineering in terms of mechanical and electrical engineering play an important role in this particular area. I think one quickly I'll mention finish maybe another 2 to 3 minutes, like saying that why the techniques are institute techniques are very useful. So I told you that when it is a real time XRD, we would taken the real time the battery while running the X-ray patterns. So as you can clearly we stop the batteries, X-ray with the different voltages. As you can see clearly, when you remove the lithium, the volume exchange means that 2003 is going to lower angle. So as a consequence, there is a volume variation, there is a variation of the lattice parameter. So the contraction expansion is occurring. So typically, so once if you buy a battery pack, they will tell the particular voltage is fixed. So try to restrict the voltage suggested by the manufacturer so that if you remove too much lithium, there is a volume expansion. Sometimes battery maybe bulging is happening. So that's why they would avoid that one. Anyway, we have some fancy techniques for neutron, or sometimes like in NMR also, people can do in a laboratory scale. So quickly, last 1 minute, I'm telling 1 or 2 minutes, I'll tell you that sustainability is very, very important. What are the research we do? This is my more on education. So, so if you remember, nearly 11 million metric tons is spent by to discard 2030. So if you don't throw in a material, for example, if you throw in dustbin, that may lead to the ecotoxicity, global warming, and health impacts, and it is very, very important. We have to we have to throw in a proper recycling. Again, although technology is known, we can either you want to be direct recycling, hydrothermal means hydro metallurgy approach, metallurgy approach. All the technology is known, or sometimes they may mainly issue is that cost of this one. The reason is that because even in battery packs, either sometimes they may use it for secondary applications. For example, our home application once is done after 15 years, again you to recover the material. You have to do sorting, discharging, battery packs, again the dismantling, pre-treatment. Either you want to be pyrometallurgy, hydrometallurgy, all the technology is known. It is not the main issue; is the cost. That's why when you're buying battery packs, some the cell manufacturers, the part of the cost is included, or some government initiatives in order to, for example, in order to, uh, especially for the recyclers into the sustainable, because for them is some government rebates also they have to give so that they run the industry. So I think this is a really issue. So we have to, at least we can't throw, we don't have any options because since these are precious metal, so to recover them. Again, the pyrometallurgy is already known. So again, a lot of large scale demonstration, industrial they demonstrated, already demonstrated in Umico, Belgium, and few other places, including few other places have been already demonstrated. So the issue is that, for example, so this here the carbon is so for example these cathodes finally end up with the lithium carbonate and different type of things. So automatically to remember so is another pyrometallurgical approach or the mining processing, recover the material, reuse them. Again, the cost is also included. So this is really I'm talking about the recovery of the materials bearing the pyrometallurgy. Again, the hydrometallurgy, have been already here, water-based system. The issue is that we use something like some acids and bases, and then the issue is again the water has to neutralize them. Then water contamination. So that's why people depending on the people, they use different type of technology. I think these are my small conclusions. There is a nice scope for a large scale manufacturing of the composite materials for energy storage. Again, the at least always you to work with both, especially for young researcher. I think now we have to adapt a little bit differently depending on the availability. So, and also we need cooperation with the scientists and researcher for the large scale manufacturing. Once again, thank you very much. Maybe I'll take some question and answer. Maybe I have another 15 minutes so that I stop early because of the many people have some questions they raise. It will be really good. And thank you very much. And again, thanks for the organizer putting this excellent FDP. In fact, I've seen that a lot of our audience. So I think for first day, few days is a 450 is a good number. So it is a really above 460. And again, the congratulations, and especially for all the attendees. I think I hope you learned something, although it is very difficult to follow within still at least a few points or one or two take home messages from the each FDP that may be really useful for your research or students are doing. That may you to motivate your students to do this. Okay, I hope you learned this FTP. You made a contact with the you people with the different things. Once again, thank you very much. Maybe I'm happy to take question and answers. I think I have some another 10 to 13 minutes time.
Thank you so much, sir, for sharing your knowledge and experiences with us. There are questions already in the chat box. Sir, can you have access of it? Or should I read it out?
Yeah. I think people are, please elaborate the disposal method available for a lithium-ion battery. Again, I think quickly I've gone through it. So here, uh, usually disposable. Okay, please elaborate the disposal method. So usual way is that disposal means if you buy any battery packs, disposal way is the proper recyclers you have to give them. So that is the way. So we can't we cannot open the battery packs, and that is not possible. So that will be again, for example, there is a chemicals, so it is not, especially the salt, everything will be there. Especially toxicity wise is not really good. I don't suggest you. So usually the battery manufacturers, they will do what they do is that they when you buy a battery pack, say there is a small amount of discharge will be there. What they do is that again they do further discharge. So if any unused this one they do, and they do something like, for example, they remove the all this one and then separating out, and then later they crush the things, and then each so there is a different way of people are doing. Either they want to do the pyrometallurgy or uh, hydrometallurgy approach. If it is hydrometallurgy approach, they soak it in the some citric or tartaric acid, some source, and then with the water. So finally, they can take out all the particular thing they extract in a. For example, again they react with it individually so that they can extract a lithium carbonate or sorry, usually lithium hydroxide or lithium nitrate type of the acetate. That is the way they can extract in one way. Another way is that if they want to work with the pyrometallurgy approach, they use react with the carbon. Another way is if it is lithium cobalt oxide, the only way is at the end they get it in the lithium carbonate as a source and cobalt as a another. So two elements have to separately and you have to recover accordingly. Okay. Uh, and then semiconductor devices made of silicon carbide is composite cell can be. Okay, so this question mark is that, and some people have raised the question. So, semiconductor device made of using silicon carbide composite itself can be blended with aluminum and others. So, as my concern is concerned, because I think if you blend with aluminum, maybe the band gap may be vary. So, I'm not sure that this aluminum blending may be. And also, one more thing is that if I remember, based on my understanding, silicon, aluminum, silicon carbide miscibility. I think the composite is a little bit difficult to prepare. So this is my so based on my understanding. So I think it's a little bit difficult. Maybe some alloys people have been trying with aluminum alloys because of the what they call as some other particular techniques people they can use. So regarding aluminum, maybe the small quantity, it depends on visibility, what type of the things, the technology they're using. So they may only they have to see the band gap. So that I'm not sure because I've not gone through very details in this particular topic. Okay. Y- Yeah. So this is my opinion. Okay.
Just at the bottom, there is a question from Shaikh Muhammad
Okay.
Feroz.
I think bottom is that okay. Okay. Usually, especially phase change material is also one more good question because in fact, so this is a little bit more detail. In fact, I'm talking about more on engineering side. I'm telling that especially the phase change materials are especially the heating and cooling. I think this is really they're using because they sometimes a coolant, especially the phase change materials also play an important role. For example, especially electric vehicle or pack sometimes during the fast chargings, the temperature will build up. So we need to cool the systems. They may use the cold phase change material, or for example, extreme high temperature. Sometimes they may use to retain the temperature. So we need to use the phase change material that also they're already using these particular things. Okay. So and also one more thing is that before cycling, there is any phase change or structure of the case of the electrode material. Okay, so these are also good questions. So people have raised, for example, Vandana Sinde. So she raised the questioning that before cycling and after cycling, there is any phase change, the structure changes electrode material. Okay, yes, there is a question mark. Usually before change, no phase change will occur. After cycling, yes, it will occur because there is a last slide quickly I'll gone through. So what will happen is that during after cycling, depending on the voltage, when you remove the lithium, the volume variation occurs, there's some phase change is occurring. So especially the lattice parameter will expand. So that is there with the in situ already we've been done. Yes, and also for example, sometimes people have been tomography. People have already demonstrated with cracks on the, for example, cathode. Some cracks also is happening with respect to the higher voltage. That's why they such a way that they restrict the voltage to 4.3 or 4.4 not not materials it has to work like this way. uh, and then another one question from the Thakur is okay, so blending is possible. I worked on the earlier that vehicle control is part of the might be like okay. Okay, so this is blending is possible. I worked on the earlier that a vehicle control is part of the components might be made with the bearing. Okay, I think this question maybe it is more on the people have raised than question. I think wait 1 minute. It's full. So the contrary part of the might component may be made with a bearing, etc. So so this question I'm not really because vehicle. So this is really with the other part I'm telling. So if you talk about the bearings, those are all the means it's possible to work on later earlier that vehicle is contrary that part of the component might be at bearing, etc. So, okay, you're talking about the blending. So I'm not talking. Clearly I'm not able to answer this question. Maybe bearings extra for this case. Again, I think the manufacturing technology is a little different. So I think people they use appropriate okay particular technique. For example, the ceramic processing, for example. So this is slightly maybe I maybe out of my things. Maybe I may ask a little bit. If you clearly explain once again a little bit different way, I can explain a little bit later stage on this one. Okay. Uh, okay. How we can send it? This is also very good question. People are Subhash Chandra show. Okay. Reflection of journal. How to send? Okay. This is also question mark again. So nowadays, too many journals are there again. There is a huge competition is also there. I am telling that I know it will be difficult because sometimes people work with mechanical, sometimes some particular things. So we have to go to specialized journal, for example. So sometimes, so really very complicated. So my suggestion is that for example, electrical engineers sometimes they select in the triple E journals, so they may focus in particular how the charging, so the protocols develop like that way. If you're a mechanical, sometimes you want to integrate this one, or sometimes people they develop some cooling system because they buy the battery packs, they use this one, some cooling system they use accordingly. They use it. That is the way respect journal. Or sometimes some people have prepared some composites, or for example electrolyte composite they prepare, and they take existing the cathode and anode, and they can make a cell, and they so there is a lot of journals. So if it is there, so power sources, and depending on the too many journals are there. So I think that is not a no because since there is huge amount of journal is existing, so accordingly try to select according to your like areas, or sometimes if it is real new materials nobody has done. Sometimes I told you that with the breakthrough energy density, if you really got it, at least you can aim for science nature. There is nothing wrong in that. So ideas are very important. If you get higher voltage, now you're getting at 4.2, 4.8, or sometimes you have maybe 5.2 or 5.5 volts. If you are able to get it, really you can aim for the science nature. That is nobody stops. Nothing wrong in that one. So, since it's a good idea, good work, so everywhere people will read. So that is my personal opinion. Okay. Or if it is not successful also, don't at least some journals, some nowadays, because an older time is different. Each time you have to submit the papers, submit by post, all this one. Now everything life is easier, automatically you can. Okay. So you can send it to any journals. So with online, I think nowadays review is a little bit faster, so that is possible. Okay. For example, if you're the computational specialist, I think already people have been, the specialized journals are there, so that is not a major problem. Sometimes a little bit big issue. Sometimes computational people will to place some experimental. They'll ask, okay, how to verify your computation? Do you have any experimental studies? They may ask. I know that they're a little bit difficult. Still, you can tell them. So due to time limitations, available, we are not able to get available facilities. Okay. So this way we can. Okay. We can just
Okay, sir.
I can see that if any questions I miss, once again I'm going back to the okay, electrical. Okay, kindly. So I think also one more question is Artish Thakur. Nickel-based composite is possible to. Okay, I think maybe some other people, if I remember. So for the orthopedic implantation means there is a bio presentation, is not by. Okay, so wait it 1 minute kindly. I think this is my previous speaker, so I don't want to touch up this particular things. I hope maybe if anything, so please write the things or you text me, so at least that will be very helpful. Okay. Till I think I have how much time minutes? I think I'm almost done, or maybe if you have 1 more 2 minutes, 3 minutes, if you want to write the question and answer. If next session is going to start a little bit later stage, then you can raise the questions. Okay. Okay. Anyway, sorry, because see, sometimes because see, one particular topic also we can cover too many things, since it is a multidisciplinary area. Some people are coming from the different backgrounds, so that's why I'll make it as a little bit more simpler. So okay, I hope you 1 or 2 points you take home message, that will be good for us. Okay, thank you, madam, thank you, and
Thank you,
okay,
sir.
thank
Okay,
you,
thank you so
animation,
much,
thank you,
sir,
madam. Yeah.
for your informative and insightful session. And I hereby announce the end of the sessions for the last day of our FTP. And I am really thankful to the speakers as well as the participants for their active participation and cooperation.